Hey, Viper chemistry students. Let's take a look at the naming of binary compounds. Binary meaning two. Bi means two. So binary compounds have two elements that join together. Um, if they're ionic compounds, that means they're charged. And so one having a positive, the cation's positive, and the anion is negative, and so they would be neutral overall. And their charge would add up to zero. But anyway, they would be attracted to each other and they would form a compound. So here are the rules. The cation is always written first, and it usually takes the name of the element itself. Now, it turns out that the some of the transition metals have more than one charge, but like for example, your alkali metals, that be group 1 on the periodic table, your alkali earth metals, group 2, they either have 1 plus charge, and in as far as the alkali metals are concerned, group 1, they're always plus 1. The group 2, the alkali earth metals, are always plus 2. Okay, so that's cut in stone. But the transition metals can have multiple charges. So you might have something with a plus 2, and it also sometimes has a plus 3. So it varies like that. So you'll just have to kind of get used to that as you practice this. And then the anions are written second. So they're the second part of the name, and it always ends in IDE. So that whenever you write something like sodium chloride, chlorine was the anion, and we've changed chlorine to chloride. And that's kind of the rule on naming that, the binary compounds. Okay, here's an example. So here we have beryllium. This is beryllium. This is the cation. It's going to be the cation. Sulfur is the anion. Now, does this cation have multiple ions? It does not, because it's one of the elements over on the left side of the periodic table. It happens to have a plus 2 charge, so that means it is an alkali earth metal. And so beryllium has a plus 2 charge. You would find it in group 2 on the periodic table. Sulfur, on the other hand, has a minus 2 charge. It's over in group 16, so it needs 2 electrons. So anyway, this combination of elements typically would then form beryllium sulfide. So beryllium being a plus 2 charge, sulfur being a minus 2, they directly go together, and that's why it's just BES. Okay, and so beryllium sulfide is the name of that. Let's look at another example here. Now here is a different scenario in the sense that we have iron, which is a transition metal, and chlorine is a halogen, which is group 17 on the periodic table. It's always got a negative 1 charge. And how would you know what the charge of iron would be? And what you have to think of is start here with the anion. Chlorine by itself would be minus 1, but there's 3 of them. So that's a total of negative 3. So there's a total of a negative 3 charge on the anion side, which means that this is iron 3 plus iron. So iron can also be 2 plus, but in this case it has to be the 3 plus because of the 3 negative charges here. So to correctly write that, we use Roman numerals in parentheses. So to indicate that this is the iron 3 plus, you would then write parentheses and then Roman numeral 3, close up the parentheses, and then chloride. So let's practice a little bit. Here are some binary compounds. How would we name these? Well, the first one is sodium chloride. We're familiar with that. Okay, what would the second one be? Well, it's potassium, which is an alkali metal, and iodine is a halogen, just like these two are. So it would just simply be potassium iodide. How about this next one here? Calcium is an alkali earth metal with a plus 2 charge, but fluorine is a halogen with a minus 1 charge, but it would still be named calcium fluoride. Now, what would be different down here about copper chloride? Well, copper is found as a transition metal, so we don't really know if it has a multiple charge or not. But since chlorine has only a minus 1, then that's why, and there's 2 of them, that's why this would be copper 2 chloride. All right, thanks for watching.